Hi, and welcome to Math 60. This video lecture is on section 2.3, and it is about working with fractions. We've already done a good amount of that. If you remember the example that I used about apples, we had 20 minus 3/2 x. And we learned how to clear the 3/2 by multiplying by the reciprocal. So some of this will be review. If you want a deeper review, there are some extra videos associated with the textbook. But I just want to remind you that to clear the coefficient when it is a fraction, multiply by the reciprocal. If I'm solving 7/5 x equals 56, if I want to clear the 7/5, I simply flip the fraction, that's the reciprocal. The 5's cancel, the 7's cancel, leaving me an x over here. And then I have a 56 times 5 over 7. This problem works out because 56 over 7, well, 56 is 8 times 7. And so the 7's cancel, and you're left with 8 times 5, which is 40. That's to clear fraction coefficients. To add or subtract fractions, you have to find a common denominator. So, for example, this is kind of just a grab bag of different fraction ideas. If I want to add 3/7 and 5/4, I can't add the 3 and the 5. I can't add the 7 and the 4. I need a common denominator. So I look for a number divisible. So divisible means that I can divide. Divisible by 7 and by 4. Now there's a foolproof way to figure that out. You can always just multiply those numbers together. 28. So 28 will definitely be divisible by 7 and by 4 because I built it by multiplying 7 and 4. So if I want to turn the denominator on the left into 28, I need to multiply it by 4. But that means I have to multiply the top by 4 because there's my number 1, right? Multiplying by 1 doesn't change the number. And over here with the 5/4, if I want to make the denominator into 28, I have to multiply by 7. I have to do it on the top and the bottom so I don't change things. And now I have the same denominator, so I'm working with the same fraction. And once I'm working with the same fraction, I can add those fractions together. 4 times 3 is 12. 5 times 7 is 35. Since they have the same fraction, I can add the numerators and put it all over the same fraction, and that's 47 over 28. So 3 divided by 7 plus 5 divided by 4 is equivalent to 47 over 28. And I'll write this there. It always works to multiply the denominators. It's not always necessary though. So if I want to, let's say I want to add 2/6 plus 5 21st. I could definitely do 6 times 21, which is 126. That would work. But I could also recognize that 6 is 3 times 2, and 21 is 3 times 7. So that means if I take the 6 and multiply it by 7, and take the 21 and multiply it by 2, I have all the same factors in the multiplication, and I get the same answer. So you can always just multiply the denominators, no matter how big they are, but often you can multiply by only a part of each denominator. So here I would do 2 over 6 times 7, so I have to multiply the top by 7 as well, plus 5, and there I would do the 21 times 2, and that means I have 14 over 42 plus 10 over 42, which is 24 over 42. A lot easier than working with the number 126. One other thing to say about that, that is a number. The top and the bottom are both even, so I could reduce 24 is 2 times 12 and 21 is 2 times 42. So in this case, I could actually reduce it and make it a fraction with a smaller denominator. All right, so that was just a quick look at some of our fraction skills that we'll use in the rest of this section. Here's an example from the book of times you might be required to work with fractions. They use A. I'm going to use X because I'm going to forget. I'll stick with X. It's just a pure algebra question, no modeling, no context here. But we're solving for X. There are a number of ways to go about this. I'm going to show you my recommendation. So we could subtract 5 from both sides and figure out how to combine it with the 1/3. But I think first I'm going to clear the coefficient, which if you think about it is technically different from the steps listed in a previous video. In the previous video, we would have gotten rid of the 5 first, but here I'm going to clear the coefficient. And I can do that. Let me rewrite it again. By multiplying by the reciprocal, which is 3/2. But I have to multiply each of these terms by the reciprocal, not just once on the left and once on the right, but every time there's a plus or a minus, I have to multiply by the reciprocal. And so the reciprocal here is going to cancel those terms, leaving me with an x plus 1. And then I have a 3 times 5, that's 15, and it's divided by 2. And then the 3 and the 3 cancel here, and I get a 1/2 there. Once again, I have a lot of different options. I could add the 1/2 and the 15/2 together, or I could clear and multiply everything by 2 to get rid of the fraction. This time, I think what I'm going to do is I'm going to subtract the 15/2 from both sides. Not a better way, just the way I'm going to do it. And that'll leave me with an x plus 1 here, and a 1/2 minus 15/2 there. These have the same fraction, the same denominator. So I can write them all over the same denominator. 1 minus 15 is negative 14. Divide negative 14 by 2, you get negative 7. And so the result is x plus 1 equals negative 7, and I no longer am dealing with any fractions. And then I'll subtract 1 from both sides, and I get x equals negative 8. I should check. I shouldn't assume that I'm done. So let's double check. 2/3 times negative 8 plus 1 plus 5 equals 1/3. So then I have 2/3 times negative 7 plus 5 equals 1/3. 2 times negative 7 is negative 14/3. if I want to add it to this fraction, the 5 has to turn into something over 3. So I'm going to do 5 times 3 over 3, which is negative 14 thirds plus 15 thirds. Same denominator, which means I can add the numerators, and I get 1/3, and that's exactly what I was looking for. So this answer is correct. All right, so that's an example of a somewhat complicated inequality. If you're faced, or sorry, somewhat complicated equation. If you have to solve an inequality, combine these skills with what you practiced in the solving multi-step inequalities, right? It's not a brand new type of mathematics. It's adding a little bit more to what you've already done. So let's talk about proportions, which are basically mathematical modeling using fractions, which is why we work on um, the fraction idea. All right, so let me give you an example. A scale model of a 30-foot tall building is 4 inches tall. How tall would a 6-foot tall person be? Person be in the model? So the way I would set this up is something like, let's see, a 4-inch tall building as a proportion of a 30-foot tall building should be the same as it should be the same proportion as an X-inch tall person who's in real life 6 feet tall. And the units are important because we're working with modeling, but sometimes they get in the way of some of the, well, I'm going to leave them here. We've got X inches and 6 feet, and I'm solving for X inches. So I'm going to multiply both sides by 6 feet. And actually, by keeping the units, it'll help us see how the units cancel. So I multiply by 6 feet here and here. The feet units cancel, and I get 6 times 4 inches over 30 should be X. And 6 times 4 is 24 inches over 30. And I can reduce this fraction because 24 is 4 times 6, and 30 is 5 times 6. So I get 4/5 of an inch is how tall that person should be. The big challenge in modeling proportions is setting up your relationship correctly. So I'll do one more of those and talk it through. The tax on a, let's say a $293,000 home is $30,140. Now I'm picking numbers that probably aren't going to work out super nice because that's life. Sometimes the numbers don't work out super nice. In fact, because county assessors are really picky, they'll go down to the penny. So the house is valued at $293,000 and the taxes were $3,143. If the tax rate is the same. What will be the taxes owed on a $317,000 home? I'm going to set this up two ways. One way, well, both ways are mathematically correct. One way is going to be easier than the other. So I might start by writing down the first number I see, 293,000, and it's a proportion, all right, because I have a number and a tax rate is like a proportion. So then I'm going to do that, and I have to match it up. If this is the value dollars, and this is the tax dollars, then I need to make sure I have the value dollars over here. And then this one would be the tax dollars in X. Totally mathematically valid, but a little bit more work to do my calculation. X here is trapped in the denominator. So I'd have to multiply both sides by X, giving me, I'm going to leave off the units just for now. This equation here, 293,000 divided by 3,140.93 times X equals 317,000. And then I would multiply by the reciprocal. It's 3,140.93 over 293,000. And I would get, I'm going to have to hop over and grab a calculator because I can definitely not do that in my head. Let's see, 317. I know you can't see this, but that's okay. 317 times 3140.93 divided by 293,000 equals 3398.21 tax dollars. It works. Usually when I set up a proportion, if I'm not thinking through it very carefully, I end up with this formulation where my variable is stuck in a denominator. And it would be a lot easier if I changed it. If I did something like, let me put the tax on the top and the house value on the bottom, because that allows me to put my variable on the top. And then all I have to do is multiply both sides by 317,000. And there's a lot less work involved. Those cancel. This number is exactly that number, right? There's the same calculation right there. And so the tax on that house would be $3,398.21. Put my units there. And since we're modeling, let's write it in the sentence. The tax on a house valued at $317,000 is $3,398.21. And I rounded that up. It was a slightly smaller number, but I rounded it up. Now, if you're saying, why do it this way if that way works just fine? That's okay. One way is not better than the other. I did want to demonstrate that sometimes when you build a proportion, you have a little bit of extra work because of how you built it. But as long as you have the top units are the same and the bottom units are the same, you'll be able to solve for your missing variable. All right, that's it for this video. Thanks for watching.